Okay, so today we're going to be talking about calculating present value when it's talking about your compounding interest or compound interest. So here's the formula for present value. That's what the P stands for, is present. A is future value. R is our rate. N is the time that it's compounded. So for example, this was compounded weekly. So our N will be 52 because there's 52 weeks in a year. And then T would be your time in years. So for this example, you can already tell I've already identified 6% as our rate. N is 52 because again there's 52 weeks in a year. So that you will accumulate, that means you don't have this amount yet. So this will be A, our future value. And then 8 will be T for time in years. So all we have to do now is just plug it into the present value formula. So we'll have P equals A, which is 10,000, divided by 1 plus, and then 6% as a decimal, you would just divide this by 100, and you would get 0.06. So that's what we're going to fill in for R. Over N, which is 52, and then it's raised to the 52 times 8 power. Alright, so when you're typing this in your calculator, and I'll show you how to type it in, let me zoom out. The best way to type it in your calculator is going to be to start with the 0.06 divided by 52. So I'm going to type that in the calculator now. 0.06 divided by 52. Hit enter, and then plus 1, enter, and then you see we have to raise it to the 52nd power times 8, so you can just type in raise to, that's this button, the arrow, and then put in parentheses 52 times 8, close your parentheses, enter. And so now we've calculated our denominator, so you can write it down if you would like, or I'll show you how to just go from the calculator. Alright, you can see that the denominator that I've written is right here in my calculator. And now from here, all you have to do is type in 1,000 and divide it by that number right here. So divided by 1.61562728. And that is going to give us a present value of $618.95. Okay, let me zoom back in. So that would be the amount we'd have to deposit in our account today in order to earn this much in 8 years compounded weekly. Alright, next example, it says how much money should be deposited in an account that earns 5%. We know that's going to be our rate. And I'm going to go ahead and turn that into a decimal. Compounded monthly, so how many months are there in a year? It's going to be 12. So that you will accumulate. This means that you don't have it yet, so that's our future value. And then T in this problem would be 6. So I'm going to go ahead and set up my formula. So I'll have P equals 9,000 divided by 1 plus 0.05 divided by 12 raised to the 12 times 6 power. And again, I'm just going to show you another way to type it in your calculator just so you'll get familiar. Every calculator is different. Alright, let me zoom out. Sorry. Okay. So I'm going to put the calculator right here so you can see exactly what I'm typing in. So I'm going to do, in parentheses, I could do 1 plus 0.05 divided by 12. So that's this portion right here, 1 plus 0.05 divided by 12. Just make sure you put that in parentheses, enter. And then I can go ahead and raise it to the power of 12 times 6. And then I'm just going to type in my numerator first, 9,000 divided by 1.3490177744, and that's that number right above here. And so my P in this problem would be $6,671.52. Alright, so for the next problem, our R is going to be 0.04. Semi-annually means twice a year, so N would be 2. This would be our A, of course. This would be our T. So I'm going to go ahead and set that up. So 15,000 divided by 1 plus 0.04 divided by 2 raised to, I'm going to go ahead and put 20 because I know 2 times 10 is going to be 20. And I've already shown you how to type it in your calculator, so I'm just going to do this one without you seeing, and you can do it on your own and we'll compare answers. So I'm going to go ahead and type this in. Alright, and the answer I got was $10,094.57. Alright, I'm going to let you work on this last example on your own, and I'll give you a little bit of time and then I'll put the answer so you can check it. Alright, for this one I got $5,169.05. Alright, so now we're going to talk about annual yield. Effective annual yield is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subjected to compound interest at the started rate. So here is the formula for calculating future value, which we did in 8.3 part 1. And then here is the formula for effective annual yield. So what we're going to do first is find the future value. So we're going to use the future value formula first, and then we're going to determine the effective annual yield with the same problem using the effective annual yield formula. So let me zoom in some. Alright, it says you deposit $4,000 in an account that pays 8% interest compounded monthly. Find the future value after 1 year. So if we deposit this much, this means that this is our present value. So this is P. An account that pays 8%, that's going to be our rate, and I'm going to go ahead and turn that into a decimal. Compounded monthly, so we know our N is going to be 12. And the T in this case is 1 because there's 1 year. So let's go ahead and use this formula to find the future value. So we'll have A equals 4,000 instead of P. 1 plus 0.08, that's our rate, divided by 12, because that's our N. And then N to the T power, well, our T is actually 1 here, so N times T in this case would just be 12. And I'll show you the best way to type this in on your calculator. So let me zoom out. So the first thing you're going to want to type in is what's in parentheses. So you can do 1 plus, make sure you put this fraction in parentheses, so 0.08 divided by 12, then close it out. Enter. And then you can go ahead and raise that you've already calculated in your parentheses to the 12th power. and then go ahead and multiply it by the 4,000. So our A is going to be $4,331 and the 99. See how the 8 is going to round up that 9? So we need to go ahead and round this to the next dollar. So our A is going to be $4,332. Okay. From here, we're going to determine the effective annual yield by using this formula right here. Alright, so in this case, our A we have already found in part A. So for A in this case, we put $4,332 equals. Our P does not change. We still are depositing 4,000. 1 plus, and the R is what we're trying to find. We're trying to find the simple interest rate. Let me scroll up. The simple interest rate that produces the same amount of money in account at the end of 1 year as when the account is subjected to compound interest at the stated rate. So that's what we're trying to find, is the simple interest rate. So we're going to just leave R as R because that's what we're trying to solve for. We don't know what that is. And then for time, we're still going to use the time in years, T equals 1. Alright, now it's time to solve for R. So the first thing we need to do is get rid of these parentheses. And we know we can't combine 1 plus R because they aren't like terms, so we're going to distribute this 400 to both terms. So we'll have 4,332 equals 4,000, and then 4,000 times R would just be 4,000 R. And now if we're trying to solve for R, first we got to move everything to the other side. So we'll start by subtracting 4,000. So when we subtract, we'll get 332 equals 4,000 R. And then from here, to get rid of the 4,000, we've got to do the opposite operation. So it's being multiplied by R. So now we're going to do the opposite and divide both sides by 4,000. So once you type in 332 divided by 4,000, you'll get 0.083. Well, this is a decimal, and we know that our rate is in a percentage always. So to turn this to a percentage, we need to multiply by 100. So once we do that, we find the rate was 8.3%. That is the effective annual yield. So what this means is that the money invested at 8.3% simple interest, so you're just paying on the interest, earns the same amount in 1 year as the money invested 8% interest compounded monthly. So we've discussed the difference between simple and compound interest, in that, you know, if you want to get the most bang for your buck, you would invest in a bank that has compound interest. But this is just comparing your money. If you wanted to compare the difference between simple and compound as far as the rate, it just means that money invested at 8.3 simple interest earns the same amount in 1 year as money invested at 8% interest compounded monthly. Alright, next page. Oops. Alright, so still working out the same type problem. It says you deposit $5,000 in account that pays 6% interest compounded weekly. We're going to find the future value first, then the effective annual yield, then we're going to write what that means. Okay. So our P in this one is 5,000. That's what we're depositing. That's our present value. Our rate would be 0.06. Compounded weekly, so N would be 52. And T in this case is 1 because of the 1 year. So now I'm going to plug that into the formula. So I'll have A equals P, which is 5,000, times 1 plus 0.06 divided by 52 raised to the n times t power, but since t is 1, we know this will be 52. So I'll just show you one more time how it's best to type that in your calculator, or how I'm typing it in. So it's always best to type in your parentheses first. So 1 plus 0.06 divided by 52, enter, raised to the 52nd power, times 5,000. Oops. So that gives us a future value of $5,308. Oops. And the 99,999 is going to round it up $1, so this will be $5,309 actually, even. Okay. And now to determine the effective annual yield, we will plug it into our formula, which was A equals, and I'm just going to write this out so you won't have to keep flipping back in your notes, P1 plus RT. So we're trying to find the effective annual yield, or the simple interest rate. So we're going to take our A, which we've already found, which was $5,309, equals our P, which was 5,000, and then 1 plus, we don't know what R is, and we really don't have to put anything for T, because T is 1, so 1 times R will just be R, so we can just leave it like that. Again, how do we solve for R? Well, we got to get rid of the parentheses first, so let's distribute that 5,000. So let me come over here. It'd be 5,309 equals 5,000 plus 5,000 R. Now to solve for R, first we'd have to subtract 5,000 from both sides. So we get 309 equals 5,000 R, and then we would divide both sides by 5,000. So R, you're looking at your calculator, would look like this, 0.0618, but we know this is a decimal and we want to turn it to a percent, so we multiply by 100 and we'll get 6.8%, 6.18%, excuse me. So what does this mean? This means that money invested at a 6.18% simple interest earns, sorry, I'm running out of room, earns the same amount in 1 year as money invested (6% interest compounded weekly. So if you wanted to do simple interest, or perhaps your bank only does simple interest, not compound, on your savings, you would get the same amount if your interest rate was 6.18%, as somebody who invested 6% interest compounded weekly. Y'all would get the same amount in 1 year. Okay, next one, I'm going to kind of let you do on your own the next two, but I'm going to go ahead and put the final answers as you're working, so be working them, and I'll put the final answers so you can check. Alright, for this one I got my answer to be 2,602.02. And my effective annual yield was 4.08%. I just rounded to the nearest hundredth. So what does this mean? Money invested at 4.08%, simple interest, earns the same amount in 1 year as money invested at 4% compounded daily. Alright, and you can go ahead and pause if you need more time. If not, I'm going to move on to the next one. And like I said, I will go ahead and I'll work it out quickly without saying anything just so you can check your work. So I advise pausing now, working out this problem, and then pressing play and seeing if your work matches up with the correct answer. Alright, moving on. Alright, so nominal rate is the stated compound interest rate. And here is the formula for calculating effective annual yield. Okay, so we're only going to go through about 2 examples of this. So it says a passbook savings account has a nominal rate of 5%. The interest is compounded daily. Find the effective annual yield. So we got to really identify what is R and N in this case. So our R is going to be rate still, and that'd be 0.05 because we had to divide this by 100. And our N will be daily, and how many days are there in a year? 365, except for leap years. So now we'll just plug it into the formula. So we'll get Y equals 1 plus 0.05 divided by 365 raised to the 365th power minus 1. So I'm going to show you how it looks like. Just type this in your calculator, the most efficient way. So of course you want to take care of our parentheses first. So we'll do 1 plus, make sure you put parentheses, 0.05 divided by 365. Then we'll go ahead and raise that to the 365th power. And then minus 1. So we will get the answer of, and we can just round to the nearest hundredth, 0.0, well, let's not round it yet, because this is not a rate, correct? Our rate needs to be in a percentage. So this is a decimal, so how do we change a decimal to a percent? We multiply by 100. So that is going to give us, now we can round to the nearest hundred, 5.13%. So our effective annual yield would be 5.13%. Alright, the effective annual yield in this problem was 5.13%. Thus, money invested at 5.13% simple interest earns the same amount of interest in 1 year as money invested at 5%. You can see with the start of our problem. The nominal rate compounded daily. So if you are selecting the best investment from 2 or more investments, the best choice is the account with the greatest annual yield. Alright, now we'll just do one more example. What is the effective annual yield on an account paying 8% compounded quarterly? So, of course, this will be our R, 0.08 quarterly, so that means 4 times a year. Now we're just going to plug it into our formula, so it would be 1 plus 0.08 divided by 4 raised to the 4th power minus 1. So I'll let you go ahead and type that in on your calculator while I'm typing it on mine, and then we'll compare our answers. Alright, for my final answer, I got 8.24%.